Hello students, today I have the key points of Coulomb's law. Now first is two charges in different media placed at different distances placed at different distances apart. Then what we have, suppose this is a charge Q1, this is a charge Q2, here is the medium 1, this is now distance R1, this is now medium 1, and the other two charges are there, Q1 and Q2. This is now distance R2. This is in medium 2. Now here the dielectric constant. Dielectric constant equal to Q1. Here the dielectric constant equal to K2. Then what the force between these two? This is now force, this is now force, this is now force F dash, this is now force F. So we are given two charges in different media separated by different distances R1 and R2. Then we have to find that what is the relation between the dielectric constant and the distance. The force F equal to 1 upon 4 pi epsilon naught into Q1 Q2. This is now Q1 into R1 square. Now force F dash equal to 1 upon 4 pi epsilon naught K2, and this is now your Q1 Q2 upon R2 square. Now this force, so much. Now what we say that if F equal to F dash, now these two forces are equal, then what will happen? 1 upon 4 pi epsilon naught K1 into Q1 Q2 upon R1 square is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R2 square. This is now your force constant is K2, dielectric constant. Then this term will cancel by this one, this will cancel by this one, and what we have, or K1 R1 square equal to K2 R2 square, or KR square equal to constant. KR square equal to constant. So if we take that if K1 equal to 1 for air, and R1 equal to R0, K2 equal to K, and for medium R2 equal to R. Then we can have from this relation that this is now 1 into R0 square equal to, this is now your K into R square. Keep in this relation. So you will have a new formula that is K equal to R0 upon R. This is to be now whole square. This is so much. This is now relation between the dielectric constant and the distance between the charges if they are placed in the different mediums. Now second, two identical conductors. Two identical conductors having charges Q1 and Q2. Q1 and Q2 are put in contact and then separated after which conductor will have charge. Conductors will have charges Q1 plus Q2 upon 2. So we are given the identical conductors. Here is the condition is to this one. At this suppose the charges, two identical conductors, this is now A, this is now B, this is carrying a charge Q1, this is carrying a charge Q2. Identical, so that this radius is also equal to the R. They are made of the same material and then they are separated. Like this is now A, this is now your B. Then after separation they will have the equal charge. Because the identical conductors, so the charge will be equally distributed between the two charges, between the two conductors. So if we follow the law of conservation of charge, following law of conservation of charge, what we charge before the contact and the charge after losing the contact, then we will have this Q1 plus Q2 equal to Q plus Q. So what we have, that this Q1 plus Q2 equal to 2Q, or this will give that Q equal to Q1 plus Q2 upon 2. This is now what? This is what we have said here. So this is for the two identical conductors. If suppose one of them is given the negative charge, if Q2 equal to negative, then this Q is equal to Q1 minus Q2 upon 2. And you can see from here that if suppose one is having the negative charge and Q1 and Q2 are equal, then this Q will be 0. So if the two identical conductors having equal and opposite charges and they are in contact and then separated by some distance, then each conductor will have a 0 charge. If Q1 equal to Q2, then this one with this will be then equal to Q. C, then Q is equal to this capital Q, then this Q equal to QI. And if we have this so we can have that if Q1 equal to plus Q and Q2 equal to minus Q, then Q is equal to 0. So they will become neutral after the separation. So this is for the identical conductors. If suppose these conductors are not identical, or non-identical conductors, what will have that suppose this is A, this is now having the charge Q1, this is now your second, this is conductor B, this is now having the charge now your Q2, they are not identical and then they are separated. This is now A, then after separation this will have the charge Q1 dash and this will have the charge B, that is charge Q2 dash. Now they are not identical. Then what will happen to this charge Q1 dash and Q2 dash? So here we will have then after separation now what we have that the first this having the radius R1, this having the radius R2, this is now radius R1 and this is now radius given to be here this charge Q2 dash and its radius is R2. This is now given. Radius are given to us. Then this Q1 dash is equal to R1 upon R1 plus R2 into Q1 plus Q2. This is now Q1 dash and Q2 dash, this is equal to R2 upon R1 plus R2 into Q1 plus Q2. तो अगर आपको इस तरह से आइडेंटिकल चार्ज कंडक्टर नहीं दे रखे हैं और उनकी रेडियस दे रखी है आपको कि भाई इनकी रेडियस कितनी है, तो सेपरेशन के बाद इन पर चार्जेस कितने कितने होंगे वो आपका ये है R1 अपॉन R1 प्लस R2 इंटू Q1 प्लस Q2 और ये हो तो आप इस तरह से अगर मान लो कि एक चार्ज इसमें से नेगेटिव हो, if Q2 equal to negative, then Q1 dash equal to R1 upon R1 plus R2 into Q1 minus Q2, and this Q2 dash equal to R2 upon R1 plus R2 into Q1 minus Q2. Only the same thing, but the difference is the radius R1 and R2. So this is for the identical conductors. And now the third point that we will have here is now then you can find the force between the conductors also. ratio of electrostatic force. Electrostatic force to gravitational force. Gravitational force. So this we take now between the two electrons. First, between two, मान लो कि आपको यहाँ दो इलेक्ट्रॉन दिए गए हैं, माइनस ई एंड माइनस ई, and this is r at distance r. So now the electrical force Fe ratio Fg, the gravitational force, this will come out to be 10 raised to the power 42. This is now relation. If suppose you are given two protons, between two protons, then this Fe ratio Fg, this is approximately equal to 10 raised to the power 36. So now 36. And third, between इलेक्ट्रॉन एंड प्रोटॉन, यहाँ पर क्या है कि आपका एक तो यहाँ इलेक्ट्रॉन है और दूसरा यहाँ पर एक प्रोटॉन है H11. Then these are at distance d. Then this ratio is so much. And if suppose you are given, no, this is not two protons. Two protons. Here we are given an electron, and then we are given a proton. The distance between them is r. In this case, this Fe ratio Fg, this is approximately 10 raised to the power 39. 39. So this is a direct. If you find by calculation, then you can do it that this will be so much, this is so much, this is not so much. Because masses and the charges of these electron and proton are known to us. And now number 4. Two identical charge balls. Two identical charge balls, each of mass m. Each of mass m are suspended by two silk threads. By two silk threads, each of length L, each of length L, from from same hook. From same hook. So what we are given that suppose this is the hook. This is now a charge ball having the charge Q. This is another. This is having the charge Q. You are given the identical charge balls. So the same charges are there, are suspended together by silk threads. Now this length of this thread is equal to L. This length is equal to L. This so much. Then they will repel to each other. This is now force F. This will also repel to this one by force F. Then there will be the gravitational force, the weight that will act vertically downward. There will be the tension T in the strings. So now what we have, that we are given now this situation, then we have to find that what will be now then you can have the tension in the strings. Then you can see that if suppose this angle is to be now theta between them, then force is acting are number 1 electrostatic force, and number 2 weight mg, the gravitational force, and third tension T in each string. So these three forces will act simultaneously on each of the ball. This is suppose the point A. This is now point B. This is now point B. Then you can see that the three forces are acting on this charge also and on this charge also, and both the charges will repel to each other. If the angle between them is theta, then you can find that this tension T equal to the square root of Fe square plus mg whole square. Fe electrostatic force, and then you can find that the angle between them, that will be given angle theta equal to 2 tan inverse. This is now your Fe upon mg. And you can see from here that the distance between these two charges, the d, this is now suppose distance between charged volts. This B is equal to your 1 upon 4 pi epsilon naught into Q square upon mg into 2L. This is not 2L. This is whole raised to power 1 by 3. This is so much. This is so much. So this is what the distance between them. This is now by this formula you can find the tension in the threads. This will give you the angle between them. And if suppose this system is carried into the gravitational free space, if this system is carried in gravitational free space, it means what? That this mg, this will be equal to 0, because they will be in weightlessness condition. It means weightlessness condition. Then you can see that this Fe will be equal to T will be equal to Fe. So tension between the strings, that will be equal to the electrostatic force. Then tension T equal to only this Fe. So Fe, this will be equal to how much? This T and this is equal to 1 upon 4 pi epsilon naught into Q square upon 2L whole square, because now they will be at the angle of 180 degrees. So this is now distance L, this is now distance L, then this is now total distance is 2L. So both the charges will be at a distance of 2L. And also you can find from here that this mg equal to 0, then theta is how much? Then this angle theta equal to mg theta equal to 180 degree. 180 degree. Because the situation will be like this. This is now hook. These are the charge Q. This is now your thread. This is now another charge Q. This is at distance L. This will be so much. So now this angle is equal to 180 degree. So because of in free space, if this system is carried, or you can have this, if the suppose charges are not equal, even in that case the system is carried in the free space, then this theta will be 180 degree. So this is what the key points of the Coulomb's law. Thank you very much.